Good evening, everyone. So in here we're gonna tackle about clustering, no? And lagay mo tag una ay we're gonna make some of the folders first. Midterm exam. And we're gonna upload some the quick access. So first guys, no, so what is clustering, no? So clustering is a technique in data analysis where similar data points are grouped together into clusters. This helps to identify patterns, categories, data, or reveal relationship within a data set. So first, we're gonna mm, make the imports. CNP, and we're gonna import pandas as PD. So import, excuse me, matplotlib the pplot as PD. So first, we import libraries, no? We start by importing essential libraries such as numpy, alias as np, is a library for handling numerical data and arrays. Pandas, alias as pd, is widely used for handling and analyzing data in a table like format called a data frame. Kita na to dire pandas. And mat matplotlib pipeplot, alias as PLT, is used for plotting and visualizing data. So ano siya guys. Mhm. So sunod df. So data na lang. Data. We're gonna use data. pd dot red csv student info for clustering that csv. So load data, no, man itong we input load data, which is this line kani siya. Loads csv file called student info for clustering .csv into a panda data frame named df. So df now contains all data now contains all the data from this file with rows representing students and columns representing different features of each student. So man siya, and next is x data. Let's select d types. So nagamit tag float, no? 64 and int 64 data. So this line, no, select numerical data. Here we create a new data frame x by selecting only the numeric columns with float 64 or int 64 data types from the data. This is because clustering algorithms generally works best with numerical data, no, mga numbers para ani makita na to. No mate. And next, import sci-fi dot cluster hierarchy as sh. So this line, we import hierarchical clustering tools. We import the hierarchical module from SciPy cluster, which contains functions for hierarchical clustering, alias as SCH for easier referencing. And then the SCH dot dendrogram SCH linkage data method equals word metric para mate including no label false true. Oh, no. So here, if we input the dend, which is the create a dendrogram, we use the dendrogram function from SCH to create a dendrogram or a tree diagram that shows how clusters of data points are joined together, as you can see. Here is what its part does linkage. So is SCH linkage or the DF method is calculate the hierarchical clusters using the word or method which minimize variance within clusters. So ang metric Euclidean is specific that we're using Euclidean distance to measure the distance between the data points. Ano na siya, guys. And no labels, just kani. Highest labels for each individual sample on the dendrogram. This makes it easier to read, especially if we're in many samples. And the dendi, which is we use the variable dendi, stores the dendrogram information which we don't use further but can be useful if we need to access the dendrogram structure programmatically. So plt dot title dendrogram X label is the samples in the PLT
So, gusto kong galing.
Euclidean Euclidean distances. So kung run. So here we as we can see, customize and display the dendrograms. So ang palette IPLT titles no adds the title, and the X label labels the X axis, indicating that each sample's data for data point in this axis. So PLTY label Euclidean distances labels like the y-axis representing the distance between clusters as they combined. They are combined, no? So ang show displays the dendrogram. Kita na to ni guys. Mhm. 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 Ah. Aha, aha. And next, no? So nata sa from escalate cluster import agglomeric agglomerative din agglomerative clustering. Uy. So kanin siya guys, no? We import no the agglomerative clustering from using from sklearn's cluster. So this is another method for hierarchical clustering that allows us to specify the number of clusters directly. Mhm. Mm. Threshold to 150. So in the second that I input, no, that is the check number of clusters formed. So it shows the actual number of clusters created by our this distance threshold setting. So we can check this value or the value to see how many clusters we found. Mhm. So let's see that n clusters. Shows mm, error. So guys, ka nag-error guys. Dili kita malangay ano ron. Ano man eh. Ano man eh. So guys, lalangay tayo ng style lang eh. Ay na, sorry guys. Ano na we So, na-fix ra day kay na ay we fixed this we master. You know what I mean, bro. And the next is let's see that and clusters as we run this version we see that we have the cluster threshold 150. We use the cluster threshold 150 and the result is 27. So if we change this to 400, we'll go to 14. The distance threshold is 14. So mhm, as we can see, no. So summary of the process: data preparation. Load the dataset and select only the numerical columns for clustering. And number 2, create dendrogram. Use hierarchical clustering to build a dendrogram, helping us to visualize the mm, how data points are grouped and identify a suitable distance threshold. So number 3 is the agglomerative clustering. Apply agglomerative clustering with a specified distance threshold 400 sa tugibot we put 400 to define clusters. So that's all. Thank you so much, besto prendo.